folks, welcome back to Common Core Algebra II. Hard to believe we're at the beginning of Unit 10. So today we're going to talk about the introduction into rational functions. Now, we're calling it rational functions, but we're really going to be exploring the algebra of the rational functions, where we're talking about the domain, the range, and basically deciding how we're going to restrict the domain of the functions. So if we take a look at exercise 1, we're going to consider the rational function given by f of x equals x plus 6 divided by x minus 3. Now also remember something, that when you have division in this situation, you don't realize it, but actually you've got parentheses around your numerator and denominator, sort of protecting them. Because so many times people want to do this. Well, 3 goes into 3 once and into 6 twice. And you can't do that because those parentheses protect it. All right? So think about that whenever you're doing anything as a fraction. All right, people are like, oh, the x's can cancel out. No, they cannot. Okay, you cannot. They're protected by those parentheses. So keep thinking about that. So A says, algebraically determine the y-intercept for this function. Well, I'm certainly hoping by this time now, it's banging on your door that if it says y-intercepts, you know that you have to set x equal to 0. So in this case, we're going to have f of x is equal to 0 plus 6 over 0 minus 3, which is equal to 6 over negative 3, which is equal to negative 2. So technically, f of 0 is equal to negative 2. Okay, so there is your y-intercept. Now, you can also say 0 comma negative 2 is your y-intercept. All right? B, algebraically determine the x-intercept of this function. So now here we go. If we're looking for the x-intercept, what has to be 0 this time? That's right. Y has to be equal to 0. So now, if you're letting y equal to 0, that's the same thing as f of x is equal to 0. So let's write our function down where it says 0 equals x plus 6 over x minus 3. Now, the hint I give you right here is a fraction can only be 0 if its numerator is 0, not the denominator. Remember, if the denominator is 0, we have an undefined fraction. All right, so we're going to say what number is going to make this equal to 0, and obviously the answer is x is negative 6. Okay, so in this case, we are looking for our point. So if it's asking for the x-intercept, it wants a point, and that point is going to be negative 6, 0. Okay, so just to remind you, if they're asking for the x-intercept or the y-intercept, that can actually be a point. But if it's asking for the roots or the zeros, those are going to be numbers. All right? C says, for what value of x is the function undefined? So why is it undefined at that value? So, I mean, I think what it's asking you to do is maybe consider putting this in your calculator and seeing where you're going to get an undefined for which x value. But very easily, we can take a look at our f of x, where we have x plus 6 divided by x minus 3. And we're going to remind ourselves that undefined is when this is equal to 0. So where is x minus 3 equal to 0? Add 3 to both sides, and x is equal to positive 3. Now, you might not have needed the algebra to do that, but basically, make sure that you are answering these questions. So I would answer this probably as f of x is undefined. Sorry about that. Is undefined at x equals 3 because the denominator is equal to 0. Well, let's say when x equals 3, even though it seems a little redundant. All right, so remember, when if it says explain or why, remember you're explaining this to somebody who has no idea what the word maybe undefined means. So you have to explain, use the definition of undefined. It means that the denominator has to be 0. All right, and the last one is based on C. State the domain of this function in set builder notation. Well, if you wanted to take a look at it, your calculator, you'd notice that the domain is everything on the x-axis except for that one point at 3. So here, if you're going to use set builder notation, the proper way to do that is x, and now we have a limitation such that x cannot equal, it's positive 3. X cannot equal positive 3. So x is all numbers except for positive 3. Okay, so we're going to move on now to exercise 2. Find all values of x for which the rational function h of x is undefined. So please make sure that we are doing some annotating, and I haven't really been stressing that enough. So let's please make sure that we're picking out the important information from these problems, especially if they're wordy problems. So we're looking for all values where our h of x is undefined, and then it says verify by using your calculator to evaluate this expression for these values. Now, the Regents exam will never ask you to do that, but I wanted you to have the opportunity to see what that looks like, but you don't have a calculator at home, so let's see where we can go with this. So if we're talking about something being undefined, we don't even want to consider what's going on in the numerator, just that denominator. And again, this is a great question because it's in combining more than one topic. It's asking you two things. It's asking you, do you know what the word undefined means? And do you know how to solve a quadratic when you set it equal to 0? So this one is a factorable, but if you're having difficulty still factoring, you can always use the quadratic formula. It might take you an extra minute, but that's about it. Just make sure you're doing it properly. All right, but this one will factor because we have a 2x and an x, and we're looking for two numbers that multiply to 6. Now remember, we have a leading coefficient here that's not 1, so we have to consider our loops. So in this case, we have, see, I have 11. I know 6 times 2 is going to give me 12, and if I put the 1 here, then that's going to work. If I put a positive 6 here and a negative 1, because this negative tells me my signs have to be different, I know this is a negative 1x, and this is a positive 12x, and they add to a positive 11x. So, sweet, equals 0. So now I'm going to bring this over to the side, and what that tells me, using my zero product law, is that one of these products has to be 0, or the other one has to be 0. And simply solve them. With the leading coefficient being a 2, here you might have to do just the slightest bit of work. Make sure when you divide by 2, you get x is equal to 1/2, or if you prefer a decimal, x is equal to 0.5. And here we simply have to subtract 6 from both sides, and x is equal to negative 6. All right? So make sure you answer the question. So I would just take a minute to say h of x is undefined when x is equal to 1/2 or x is equal to negative 6. Okay, not really a hard question to do, but understanding what the word undefined is half the problem there. All right, exercise 3 is a very similar exercise. It looks a little bit easier because it's a multiple choice question, but it's the same question that we just looked at. Which of the following represents the domain of the function? So what we have to do is take a look at our answer choices here. Our answer choices show our set builder notation, like this number 4 that's right here says x such that x doesn't equal 3 and negative 6 and 3. All right, so it's the same situation. We're looking for the domain restriction. So where our denominator is equal to 0. Now again, this is a nice, easy, factorable quadratic, and you get x and you get x, and you get minus 8 and plus 2, because here it's negative 8 and plus 2, our leading coefficient is 1. So we have x minus 8 equals 0, and x plus 2 is equal to 0, or if you like using that word, add 8 to both sides. So x is equal to 8 minus 2 from both sides. X is equal to negative 2. So at both of those values, it's going to be undefined. So which one is it going to be? Negative 2 and 8. So the answer is right here at number 3. Okay, moving on to exercise 4. If g of x is equal to 3x minus 2, nice linear function, and f of x is equal to 2x plus 1 over x plus 5, then find f of g of negative 2. So we're going back to composition here. This really doesn't have that much to do with what we're talking about now, but it still is a nice reminder on how to do composition, because we're going to pull this into something a little bit more complicated later on. So we have f of g of negative 2. So the first thing we want to calculate or evaluate is g of negative 2. So let's go to our g, and that equals 3 times negative 2 minus 2, which is negative 6, minus 2, which is negative 8. All right, so our g of negative 2 is equal to negative 8. So now what we're going to do is now we're going to do f, and we're going to put in our negative 8 where our g of negative 2 is. So f of negative 8 is going to be 2 times negative 8 plus 1. That's our numerator. And then we have negative 8 plus 5. And again, I'm going to remind you, when you're evaluating this, please use your fraction bar on your calculator, or you can also just make sure you're calculating the entire numerator and the entire denominator and doing the division last. So if we do this, we get negative 16 plus 1, which is negative 15, divided by negative 8 plus 5, which is negative 3. So my answer is a positive 5. Now, why don't you pause the video and try and do B and C on your own. Follow the rules that we just went through and the process that we just did in A, and see if you can follow that in B and C. I'm going to just move that up so you can see both of them, and you have them on your page. So go ahead. So hopefully you started with g of 2, and that is equal to 3 times 2 minus 2, which is 6 minus 2, which is 4. So g of 2, and if it helps you, write it down. G of 2 is equal to 4. So now we're going to substitute in here. We're going to substitute 4. So I'm going to evaluate now f of 4, which is equal to 2 times 4 plus 1 divided by 4 plus 5, which is going to be 8 plus 1, which is 9, over 4 plus 5, which is 9, which is equal to 1. And C, because this one has no number here, we're just going to start with g of x. So we know g of x is equal to 3x minus 2, and we're going to substitute that in wherever there's an x in our f of x. So f of x is equal to 2 times x plus 1 divided by x plus 5. And wherever there's an x, we're going to put in our 3x minus 2. And now we're just going to simplify it. So when we simplify this, we get, and let's look at our numerator. So we get 6x minus 4 plus 1. And in the bottom, I have 3x minus 2 plus 5. So now we just combine like terms. and we get 6x minus 3 divided by 3x plus 3. Now, you can leave it that way, but if they want simplest form, basically what we can do here is we can factor out a 3, and I'm running out of room, sorry about this. We get 2x minus 1 in the numerator. We can factor out a 3 in the denominator and get x plus 1 in the denominator, and the 3's now cancel. So my final answer is going to be, and I'm running out of room, so where am I going to put my final answer? How about I put it right over here, because I have a little bit of room left over where b was. So our final answer to this is going to be 2x minus 1 divided by x plus 1. Okay, we have two more quick examples to go over. So if you need a little bit more time, write down what you need to, pause it, and then meet me at exercise 5. So 5 says find the formulas for the inverse. So find formulas for the inverse of each of the following simple rational functions below. Recall that the first step, now remember, they're not going to give you this information. You have to remember that you have to switch the x and the y and then solve for y. So in this case, we're going to solve this one for y. So first thing we're going to do is switch them. X is equal to y over y minus 2. Now we have to solve this for y, which looks like it's not going to be so easy, but we can simply just put this over 1 and cross multiply, and we get x times y minus 2 is equal to 1 times y, which is y. So we get xy minus 2x by distributing the x to both of those terms is equal to y. Now we have to isolate the y. So what I'm going to do is I'm going to bring this xy over, minus xy, hope I don't run out of room here, minus 2x is equal to y minus xy. And now I am solving for y, right? So I'm going to have to factor out that y on the right-hand side. So factor out a y, and you get 1 minus x is equal to negative 2x. And now simply divide by the 1 minus x. And there is your inverse. These will cancel. So we get y is equal to 2x over x minus 1 over 1 minus x. It's 1 minus x. There's a negative 2 here. All right, so you get negative 2x over 1 minus x, or you can write this a different way as positive 2x over x minus 1. We're going to talk about that a little bit later. So these are equivalent functions. Okay, so let's look at B. And simply, again, we're going to just flip those two. So let's do this first. How about x equals y plus 3 divided by 2y. And we're going to cross multiply. And we get 2xy is equal to 1 times y plus 3. And we're solving for y. So let's bring this y over to the left this time. So minus y from both sides. And we get 2xy minus y is equal to 3. Remember, we don't have like terms. We can't add or subtract them. But we can factor out a y now. We have a y on the left and the y on the right. All right, so we're going to factor out a y. And then we have 2x minus 1 left over is equal to 3. And now simply divide both sides by 2x minus 1. And if you feel better putting it in parentheses, that's fine. Put it in parentheses because sometimes you just feel better when it's protected. So y is equal to 3 over 2x minus 1. with or without parentheses. All right, now last exercise of the day. The function f of x equals x squared minus 8 divided by 4x is either even or an odd function. All right, so they're telling us it's not either one, it's even or odd, okay? So then it's saying determine which it is and justify. So based on your answer, what type of symmetry must the function have? So part of me kind of thinks that you need to know that before you can tell me if it's even or odd. So the second one is just a justification. So in this case, it's telling us this is the function. It's telling us it's even or odd. Make sure to determine which it is and justify, okay? Based on your answer, what type of symmetry must this function have? So this is one of those multi-step problems, and it's really important to make sure that when you think you're done, go back and read the question again and make sure you are done. So if it's an even or odd function, I think the easiest thing to do is go to your calculator. So very easily, you can put this function into your calculator, and nicely enough, I've already done it for you. So here's the function, f of x in the blue, and this is the table. So I put the table here for you so you could see what that looks like. So if you can see, it's negative 1, 1.75. At 0, it's undefined. And if you take a look, if you go down, what happens at positive 2? Sorry, it's just resetting. At positive 2, it's negative 0.05. So which type of function, even and odd, gives me opposite inputs and opposite outputs? Do you remember? Yeah, that would be even. All right, because it would be odd because even functions give you the same outputs. So in this case, so let's just quickly just jot down what that table looks like. X, Y. So negative 3, negative 2, negative 1, 0, 1, 2, and 3. And it was negative 0.083, 0.5, 1.75. At 0 was undefined. Then it was 1.75, whoops, negative 1.75, negative 0.05, and positive 0.0833. So you would write here, this is f of x. F of x is an odd function. Now it's asking us to justify, so we know we need the word because, and use the definition of an odd function. Because opposite inputs yield or give us opposite outputs. All right. Now it asks us, based on your answer, what type of symmetry? And we know that this gives us symmetry across the origin. All right. Odd functions give us symmetry across the origin. So I'm sorry that video took a little longer than I've been trying to keep them at like 15 to 20 minutes tops, but there was a lot of writing in that one. But I don't think this is a very difficult lesson. I think there's a lot of different things that we've done in here that really apply to what we've done in this course thus far. So again, these are great questions because it's asking about things like, what's the domain? Where is it undefined? What does the function look like? Is it odd? Is it even? And using your calculator for all of this is really important. All right. So until next time, we are done with 10.1, and I'll get 10.2 uploaded any day now. And until next time, as always, and I know you're tired of hearing it, but please, please, please make good choices.